Hello. Okay. Thank you for this opportunity. I'm Joseph Ahn in WeMB from South Korea. I'm gonna share my screen. So first of all, thank you UTA for this opportunity to speak today. And I'm going to talk about managing smart cities through digital twin technology today. And I will briefly touch what digital twin is, then we'll introduce WeMB products and a couple of application cases. So please understand that I can just talk about just basic ideas of digital twin and its core technologies, as the time assigned to me is kind of limited. So I cannot go through them deeply. So please allow yourself time later to search on these topics in detail. So let me start. So the first question is that what is a digital twin? I believe many of us are familiar with the term digital twin. These days, digital twin comes up when we discuss the smart city. So simple definition is a virtual representation of any physical or tangible object, occasionally intangible, of course, in the digital world. So why and what is digital twin is used for? Before executing a plan in a real world, digital twin enables operators to simulate and test whether the plan will be effective or not through the digital model. So it predicts and provides insights with this in real world. Instead of trial and errors, operators can manage their limited resources more efficiently and reduce any potential risks. So though they are slightly different, prestigious researchers expect digital twin market to grow 62% every year on average, and the market size to be almost $30 billion by 2025. Among the world, the Asia Pacific market is expected to grow most and fastest. So application of digital twin. So where can this technology be used? Nowadays, it is hard to clear cut. It can be used even in healthcare or hospitality industry, university, etc. But fields where the technology is most used are no doubt machine testing, of course, because it started with the GE, which manufactures machines and to test their performance or simulate the outcome. And smart factory, of course, and smart building. And it also can be used smart city, and WeMB recently used this technology and apply on the managing smart city. So by applying the digital twin in smart city, various issues in city operation can be solved or mitigated. Those issues are related to safety of citizens or energy consumption or efficient usage of energy or management of aging infrastructure, prevention of or response to catastrophic accidents, or optimized and efficient operation of city, etc. And there are two fundamental elements for digital twin and supporting technologies. First, similarity. A digital twin, especially the digital twin must look the same as a real world object as much as possible. Otherwise, it'll cause confusion and inconvenience to use. For similarity, accurate visualization without blind spot, such as 3D modeling, is necessary. The second is data and information. The data is heart of the digital twin. Without the data or information, digital twin with 3D modeling only is like a car without engine. More and better quality data exists, a more accurate performance and outcome be guaranteed. For smooth data flow, network and communication technology is a foundation. Over it, Internet of Things or big data collection and processing and cloud and edge computing and AI-backed prediction technologies are required. Among these technologies, WeMB develops and delivers solutions that have a powerful 3D visualization function, as well as big data collection, data analysis, and AI-backed prediction. So briefly talking about what WeMB is and what we do, the more details are actually placed the later in this file, but I'm just going to touch just briefly because of the time. So the WeMB is based in South Korea, and it's a leading company of a digital twin and real-time monitoring and data processing in South Korea. So since 2004, its foundation, for 18 years, it served over 150 customers and carried out over 500 3D digital twin projects. So in the beginning, it did simple dashboards, data center, or building. Now developing its technologies and products that can be applied in more complicated environment, such as smart city or port or infrastructure management. So because of software, I cannot show you the physical picture of the product, but please understand that. So to build a 3D digital twin, WeMB presents two core products, one for data collection and analysis. The other one is for visualization, real-time monitoring, and simulation. So the TIM is a powerful, TIM, which is the Total Integration Manager, is a powerful data collection and analysis tool. It collects data from any data sources, such as IoT sensors or data generating equipment or legacy systems with a simple and easy configuration. So it stores the data in the data warehouse and analyze it. Now, recently, we also upgraded the software so that it can perform the big data analysis or AI-based prediction. And then Renovate, a dashboard and 3D visualization tool. It loads the analyzed or raw data and visualizes it in the form of dashboard or 3D digital twin. Also, visualized model reflects on real-time operational data. The users feel that they stand on a real site and see what is going on or urgent events, though they are not physically in the real site. Also, Renovate is provided with the editor. So any environmental changes or addition of data sources, users easily can configure and maintain the system by themselves. So I'm gonna just briefly go through the two use cases for the city management with the WeMB products. So these are the couple of pilot projects that have been done with the WeMB products. The first case is a smart city management platform developed for the area called Toyosu in Tokyo, Japan, in the early this year. Due to requests by co-working partners, the version I'm presenting now is a small part of a pilot system that we cooperated with one of the biggest Japanese firms in order to promote the smart city management business in Japan. So the main issues to improve through the system were a severe traffic congestion in especially rush hour, or mobility of the disabled, especially in a disaster situation, and monitoring aging infrastructure, etc. The system was developed using the third-party 3D map software, data shared by the governmental institution or participating companies based on the WeMB solution. Let me show you the demo video of the pilot system. So once the pilot system starts, the 3D visualized Toyosu area appears. It was supposed to display real-time traffic flow with colored lines here and parking spaces occupancy status, but the information was removed in this video due to the co-working partner's request. So this is the 3D visualized Toyosu's area. So you can see the whole city without blind spot. Once you click it, you can enter the building. So the system collects data from every sensors or system that are used inside of the building. And they can be like temperature or humidity sensors or leakage sensors or earthquake or fire sensors or etc. So the advantage of the 3D digital twin is that it shows the exact location of the events or sensors or equipments so that it increases the visibility of the users. Also, the system can show real-time performance and event status of individual devices, such as IT device or any machinery or facilities. And for example, here, air conditioning system, so that the users can see the current status of the machine or historical information or the event status. Also, I'm going to show you the purpose of this system was to tackle the fire situation or any disasters and manage them in more efficient manner. So for example, here are two persons wearing real-time location tracking sensors. And the system also pinpoints the available exit so that as Mr. Nakano with the green name tag here is moving, whereas Mr. Morishita with the red name tag cannot, as he is disabled. However, here's a certain fire sensor detects a fire event. As the system detects Mr. Morishita is disabled and cannot evacuate by himself, it alarms safety staff to notify the exact location of Mr. Morishita and approach to him to rescue. The system collects data and analyzes the pattern to identify a disabled person and visually pinpoint the location of the person to secure the safety of the person in emergency situation. So because of time, I'm going to close this video, but hopefully this presentation and video can be shared after this session. The second case is the port management, which is a part of the city. The version I'm going to presenting is also a pilot system that was made and tested in a mega-sized commercial port in Singapore. So the main purposes of the system is monitoring major events such as fire, storm, or worker safety and supervising vessel operations. Also, it is for measuring real-time KPIs to improve productivity of the port. Sorry for the sound. Okay, so once the system starts, the 3D view of the entire port appears. The modeling was made based on AutoCAD file with the 3D view on the center. Surrounding items are real-time KPIs about productivity, operational efficiency, or major equipment status, or cargo throughput status, or major events taking place in the port. And here, also with analysis of the data pattern, the system predicts throughput and productivity. Also based on the up-to-date data, it predicts monthly and yearly productivity so that with this information, the operator can deploy or adjust the number of workers for efficient use of the human resources while they are increasing the productivity in the port. Also, it shows that how to deal with the events such as fire or earthquake when it happens. So fire events has to be quickly and efficiently managed. So once the fire breaks out, the 3D view shows the exact location of the fire location. So on the pop-up, the operator can notify the managers, workers, and nearby fire station. Also, it can see the evacuation status of workers inside who are wearing the location tracking tag. The system can also guide on optimized evacuation route based on analysis of the data generated and received from sensors inside the warehouse. In addition, the system can track and predict the cargo unloading status. The operator can utilize human resource efficiently to finish the job on time. So the advantages of WeMB products are powerful 3D visualization to build a digital model. It enables users to do a quicker and faster response to situations by pinpointing an exact location in the 3D digital twin. And with the monitoring real-time situational awareness and prediction function, it can improve the management of the city and make it more efficient. Let me see. So the following slides are about the detailed information of WeMB, but I'm not sure because of the time, I cannot touch these points, but probably I hope this file can be shared after this session. Or if you have a question, you can email me. So I hope I might not be sufficient to explain fully about our products in 15 minutes. So please email me if you have any questions. So thank you for your attention and this time.